Hi, welcome to inserting an element into the binary search tree. Here we will start always from the root. Initially we are checking the tree is empty or not. So if tree is empty, the new node will added as a root. Then again we will pass the another element in the existing tree. So now root will be available. If root is available, then we will check the given element is less than the root value or not. If it is given elements, for example here it is 5, then I am going to insert 7. Now we are checking the 7 with 5. If 7 is greater than the root value, then that will be added as a right sub right child in the right subtree. So here right subtree is null, so that will be added as a right child. Then next element, if I going to insert 2, we are checking again with the root value. So 2 is less than the root value 5. If it is less than the root value 5, traverse towards the left subtree. When I am traversing towards the left subtree, 5 is having null in the left subtree, so then 2 will be added as a left child to the 5. So this will be continued until given number of elements. Now here we are passing the node here. We are passing the node we are passing the root node actually. Then given data is 4. So now here root node is null, then data is passing 4. So here we are checking root equal to null. Yes, it is true. So what we are doing, we are uh, returning the node. The node is here. What is the returning node? Data is going to be a root node. Data is going to be a root node. So this is data actually. Data is going to be a root node. So now 4 is the root node. Then next time we are reading the 5. So when we are reading the 5, we are checking here. Now root is we are passing as a 4 and reading data is 5. So we are passing these values. Now we are checking root equal to 4, 4 equal to null, which is false. Then we are checking the another if condition. Data is now 5 less than node is here 4, 4 dot data is this one. So this condition is false. 5 less than 4 is false. So the true block will not execute. The false block is having the one more if statement. The data is here 5 greater than node data is 4. Yes, it is true. Then inside this else block we are having another one if condition. Node dot write. So now node is 4, 4 dot write, 4 dot write not equal to null. So 4 dot write is null, as of now null. So this condition is false. If it is false, the else portion will execute. In the else portion, for the data 5, we are creating the node 5. We are creating the node 5 with the left child pointer and right child pointer. So that will be added as a node dot write. So here the 4 dot write. So 4 dot write will have node 5. So 4 dot write will have the node 5. Then next time when we are passing the next value 2. So 2 we are passing here. The root value will be same 4. This is the root. So root is 4 and we are passing the value going to read is 2. So now root is not equal to null. This will be a false. It will not execute. Now we are checking data less than root dot data. So node dot data is here 4. So 2 less than 4, which is true. So if it is true, the true block will execute. Now we are checking 4 dot left. 4 dot left not equal to null. So 4 dot left is actually null. So this condition is false. If it is false, then this will not execute. This else block will execute. So else block here, what we are doing, we are inserting the no we are inserting the data. The data is here 2, which is going to insert here. So for the data we are creating the node. So no, for this we are creating with the left child pointer and right child pointer, that is going to be added as 4 dot left. So 4 dot left will have now 2 with the left child pointer and the right child pointer. Okay, so now again I want to insert the fourth data into the tree. So when I want to insert fourth data, so here the fourth data is 6. Fourth data is here we are going to insert 6. And here we are passing root node value. Root node value is 4 and inserting data going to be 6. We are checking the root is null. No, it is false. Then we are going to the next if statement. Here data is 6 less than node data is 4. So 6 is greater than. So this is false. So this will not execute. So false block is having if statement. Here data is 6 greater than node data is 4. Yes, it is true. So inside that we are having one more if statement here. Node dot write. What is the node dot write? So here the 4 is the node. So 4 dot write not equal to null. So 4 dot write not equal to null. Yes, it is true. It is true. When it is true, we are passing node dot write. What is the node dot write? So 4 dot write is now 5. So here we are passing the 5 comma the data is here 6. Data is here 6. So we are calling the recursive call insert of 5 comma 6. So 5 is going to be node here, root node here, then 6 is the data. So in the recursive call now we are passing 5 is the node, 6 is the data. Now again we are checking data is 6 less than 5, so which is false, so it will not execute. So it will come to the else if statement. Here 6 greater than 5, yes it is true. So when it is true, now we are checking 5 dot here what is the data node? So 5. So 5 dot write not equal to null. So 5 dot write not equal to null, which is false. Which is false. If it is false, then this else portion will execute. In this else portion, we are going to insert the data 6 into the right as a right node of the right node of the 5. So now for the 6 we are creating the node with left child and right child pointer, that is going to add as a 5 dot right. Node is now 5 dot right. So 5 dot right will have the 6 with the left child pointer and right child pointer. So then we are going to insert node another node 3. Here also we are going to pass root value is now 4. The data going to be insert is 3. Now we are checking root is null. No, it is false. Then we are coming to this if statement. In this if statement we are checking data is 3, node data is 4. So this condition is true. So this true block will execute. Then what is the node here? Node is 4 dot left not equal to null. So 4 dot left not equal to null. This condition is false. This condition is yes true. Condition is true because you look at that 4 dot left is not equal to null. Yes, not equal to null. Then it is true. When it is true, we are calling the recursive call node dot left. What is the node dot left? 4 dot left. 4 dot left is now 2. The data going to pass here is 3. So 2 comma 3. So we are calling the recursive call insert of 2 comma 3. So now for the 2 comma 3 again we have to check the recursive call. So in the recursive call now in this for this 2 comma 3, so node will be 2, data will be 3. So now we are checking root equal to null, false. Then we are checking here the data is 3, node data is 2, so which is also now false. If it is false, true block will not execute, else block will execute. In the else block we are having data greater than 2, node data is 2. Yes, it is true. Inside the true we are having one more if condition. Here we are checking node dot write. Node dot write is 2. 2 dot write not equal to null. So 2 dot write is null. 2 dot write is null. So this condition is false. If condition is false, else block will execute. In the else block we are going to insert the data 3 as a right node to the node the data is 2. So now for the data 3 we are creating the node with left side and right side pointer. So now the node dot right, the node dot right is here, node is now 2, so 2 dot right, so 2 dot right will have the node 3, so 2 dot right will be having the node 3, so which is having here null, here also null, so all the leaf nodes will having the null. Okay, so now the all the values are inserted into the binary search tree. Now you check the binary search tree property. The root node is greater than the left subtree, left subtree, you look at that. So here 2 is less than the 4, and here 3 is also greater than 2, less than the 4, greater than, this is 3 is greater than the 2 and here less than the 4, right? Likewise in the right subtree 5 is greater than the 4 and less than, so here less than the 6, and 6 is also right child, so greater than the 5, so which is satisfying the binary search tree properties. Thanks for watching.